command interface for the worm. It's got an administrative shell, or it can be a network line. It accepts instruction either from a person or from another worm node. How do they communicate? Information transfer, protocol, stealth concerns are there for the worms, the intelligence database, knowledge of other nodes, concrete versus abstract, complete versus incomplete. So it has an intelligence database which can differentiate between these and propagate. Some of the famous Unix worms have been detailed here. They're quite old, but Slapper worm was very famous, Ramen was famous, Cheese worm was famous, Lion worm was famous. If you need to know what exactly these worms did, just Google it. You'll get detailed case studies on how each of the worms infected the systems, how they brought down the systems, and how they were detected. Yeah, enough with the worms. Now let's talk about what is a Trojan. It is a small program that is designed to appear desirable but is in fact malicious. It must be run by the user. It does not replicate itself. It is used to take over a computer or steal or delete data. Good Trojans will not alert the user, alert the way that the computer works. If you have seen or heard of the actual meaning of Trojan came from an old saying, beware of the Greeks bearing strange gifts. Now, there was a wooden Trojan horse with hundreds of soldiers inside, and they used the Trojan to gift it to the enemies. And then, once they were inside the boundary walls of the enemy camp, hundreds of soldiers came out of the Trojan horse and attacked them. Similarly, a Trojan, if you want to define it, it is an unauthorized program within an authorized program which executes whenever the authorized program executes. In a little more simpler term, it is a program which appears to be legitimate but performs unintended actions. Trojan horses can install backdoors, it can perform malicious scanning, it can monitor system logins, and also do other malicious activities. Now, it was an easy weapon for script kiddies to wreak havoc on the internet. Script kiddies was actually a term coined by sophisticated hackers for the more immature hackers, but equally as dangerous. And Trojans are a program that hides behind a potentially valuable or entertaining program. Trojan horses can be viruses or remote controlled programs that provide complete access to the victim's computer. So like I said before, it is an unauthorized program or a malicious program that resides within the authorized program or the legitimate program and runs whenever the legitimate program runs. But majority of the Trojan horses, the modern ones, are backdoor utilities. A sub7 is one, NetBus is another, back orifice is the third. So there are several Trojan horse programs available. Now what are the features of these Trojans which are backdoor utilities? They basically include remote controlling, desktop viewing, HTTP or FTP server, file sharing, password collection, port redirection. So basically the functions that backdoor utility program can do are these. Some of the Trojans can be used as legitimate remote administration tools. Other Trojans are mostly programs that steal data or delete data or can even drop a virus. The best Trojan is the one that you don't know is a Trojan. In Unix login, if you take for example, there is something called port redirection. So hackers use your connection to attack and then you get blamed. That's an example of a good Trojan or a Trojan with good Trojan properties. Then there are Windows backdoors, back orifice 2000 was another, NetBus, Windows VNC, virtual network computing, Sub7. These are all some examples of the Windows backdoors. What does a backdoor do? A backdoor allows a malicious attacker to maintain privileged access to a compromised host or a compromised system. Unix backdoor are typically installed via a rootkit or manually after a system has been initially compromised. Windows backdoors are typically installed via a virus, worm or a Trojan horse. Virus and worms via email, example of them. Sharing infected files, opening Windows shares, and Trojan horses typically included with legitimate application such as a game that you download from the net can have a Trojan within that. Then we'll see what is a logic bomb. We have already explained what a logic bomb is. It is designed to be extremely malicious. It is very hard to detect. It runs after a certain amount of inactivity or in the absence of certain activity. In the example that I explained earlier, if my name does not appear in the payroll in the 7th of the next month, then do a del star dot star. So that's an example of that. It's engineered for maximum effect. So all the data is wiped out. Now, as an example, some malicious logic bombs can take advantage of the error in machine code and start a processor on fire. Basically, it inundates the processor with so many requests and so many cycles that the processor ceases to function. Now, Tim Lloyd of Omega Engineering Corporation on July 31, 1996, a logic bomb executed causing a loss of its key manufacturing program, resulting in a loss of more than $10 million. There are only 6 lines of code in that. del3.exe modified to 4z read fixing instead of deleting it, and used purge f:root, so everything was deleted. If you do an analysis of the code, you can find there was a bizarre code in this. Why did the computer shut down unexpectedly? The computer got very poor and decided to end its own suffering. So the computer decided to suicide. Makes you wonder what else is in it. So careful analysis of the code is required to find out if there is a logic bomb hidden or written. Even in Unix, backdoors are typically a shell bound to a network port. A remote attacker can connect to the network port and execute commands. A Trojan domain, such as an SSH, that is your secure shell, used to connect the server from a remote place, may provide root access without a password. So the backdoors in Unix cause a Trojan domain such as an SSH, which provides root access without a password. Rootkit is a collection of tools that allows the hacker to provide a backdoor to the system, collect information about other hosts on the network, hide the fact that the system is compromised. It hides the intruder's activity on the system. It allows the intruder to keep the privileged access, not to initially obtain it, but to keep it. Rootkits are Trojan horses and typically provide a backdoor. Most rootkits can be detected by running an integrity checker. Now, for example of an integrity checker is Tripwire. The original rootkit was distributed from bulletin boards. The public remained unaware for many years. Finally, it was made public in early 90s. Now, it is widely available for many platforms. It includes an Ethernet sniffer to help find accesses to other servers. Once the superuser or root privilege is obtained in a Unix-based OS, then it looks to trusted hosts It can modify key programs and override them in the operating system. And the newer kernel-based rootkits are very hard to detect. Example is NARC. The cost of malware. It's not only the money that is spent on hiring staff to repair damage and recover data, but there is also a lot of time invested. Again, the staff require time to repair the damage, to recover the data, to supervise the temps if they are outsourced. Then there is a question of your reputational risk, unexpected downtime, even if it is a website or a library where the files are stored. It causes the customers to go elsewhere because your site is not up. Then there is a question of trust. The customers trust you with their personal information. Vendors trust you to authenticate your users. If that does not happen or if your server is down, then it's a huge cost to bear. Let's take a look at phishing. Let's go back to how phishing started. It dates back to the 90s. It was used for stealing America Online accounts. But it took off for banking from 2003 onwards with the advent of internet technologies coming in, with banks going online for transactions, the customers going online to do transactions on a banking site. The underground economy allowed criminals to specialize in phishing. It initially used confusing domains. Example, https test.com. It sounds legitimate, but it's actually not. Phishing also is propagated with poorly spelled email threatening with your account closure. Now, in this regard, there was an incident in one of the financial institutions where a customer was called by some malicious person, and told to give his password for the internet banking account, claiming that he was from a regulatory authority. The customer did not give the credentials. But then the next morning he received an email that his account was suspended or account was closed because of his not providing the password. Then he actually went to the bank and asked the manager what happened to this. They found that an amount was withdrawn from his account. So a lot of phishing activity was done, even though he did not verbally give his username or password. The hackers managed to exploit his system using browser-based malware and started transacting with his or impersonating him. Then, if you go on, the phishers discovered that the people didn't understand URLs. For example, http www.test.com at example.com. So then the next step for them was to stop using fixed websites. In fast flux hostname points to a relay, a machine from the botnet. In 20 minutes, it points to a different relay. So it is not a static site. It's a dynamically changing site every 20 minutes. So it becomes difficult to identify. Today, phishing is much more sophisticated. Many attacks on non-banks also and return of domain names. There is an example given there. eu.battle.net, account blizzard en wow.in. The HMRC really attacks on credit cards. The fake pages are now mainly in attachments, not as a mail body itself. It's considerably more complex to explain a hosting company why a website with a code to accept the HTTP post should be disabled. Generally, since it is a hosting company, it's very difficult to explain to them because they are serving millions of customers, thousands of customers. It is very complex to explain to the hosting company why a website with a code to accept HTTP post should be disabled. And there is a research by Moore and Clayton that is fake websites removed within 4 hours, or 4 days if a bank does not know that they exist. When URLs are detected, no incentive to share them for free. Data also relieved slow removal of mule recruitment websites. Currently it's out of fashion, but were lasting for at least 13 days. No, it's no one's specific problem, so no one deals with it. A variation of phishing is form phishing. It's a security email which directed the recipients to website to protect their account. Suddenly you will receive a message from a bank stating that go to this website, change your credentials immediately. That's a form of form phishing. And phishers use legitimate graphic to replicate phishing web page. So when you look at the mail body, it looks exactly from as though it has originated from the bank. If it is XYZ bank, the logo of the XYZ bank, the color combination, the font, everything will be the same. But actually it is a kind of form phishing. The banks generally do not ask information about your personal information over the net or through phone. So the form phishing takes advantage of the fact you can't fool all users, but you can fool some users. Then there is clickjacking. It happens when a scam artist or other internet-based bad guy places an invisible button or other user interface element over the top of a seemingly innocent web page using a transparency layer. As user, you will not be able to see that. The innocent web page might have a button which reads something like click here to see a video of fluffy kitty being cute and adorable. But hidden on top of that button is an invisible button that is actually a link to something that you would not otherwise want to click on, such as a button that tricks you into changing the privacy setting of your Facebook account, or tricks you into liking something with you normally wouldn't like. It's also known as likejacking. It tricks you into adding yourself as a Twitter follower for someone who doesn't deserve you. It tricks you into enabling something on your computer, such as a microphone or a camera. It tricks you into running into a crowded theater and shouting Shizu at the top of your lungs. Many times the clickjacker will load up a legitimate website in a frame and then overlay their invisible button on top of that real site. Basically, the cure for clickjacking is you have to update your browser to the latest version. Use all your plugins such as your Adobe plugins or Flash plugins should be updated. There are also softwares which are free which can help you detect clickjacking. Again, there is something called a scareware. We have looked at phishing, we have looked at clickjacking, we have looked at malwares, we have looked at virus. Now there is something called a scareware. Scareware is designed to trick you into buying something or installing something that could be potentially dangerous. This is also another medium for criminals to load malware on your computer. But why do they do this? What's in it for them? It's all about money. There are malware affiliate marketing programs where criminals pay other criminals to infect computers. The participants make money based on the total number of computers they can infect with the malware. Now, in simple terms, how do you avoid scareware? Never install software that has not been researched. There are also methods to tap your cell phone. A link is given on how it has been done. At your leisure, you can go to the link and learn about how the cell phone was tapped. Now we come to the conclusion of this particular aspect, where we have seen what a virus is, what a worm is, what a parasitic virus is, what a bacteria is, what a Trojan horse is, what are the internet or what are the antivirus scanning technologies, inoculators, integrity checkers. Then we have seen about different forms of attacks such as clickjacking, scareware, phishing, form phishing. Now we will end this particular session